Yesterday we left off with Destiny being sorry. We left off with beginning of the binomial theorem. So the binomial theorem states a plus b to the nth power. A plus b to the nth power is equal to the sum. I'm going to give you what this means. Throw it in the trash. That's your fine.
But I got you a present. It's yellow.
It's okay. Wow. Okay. So, the sum as k goes from 0 to n.
Well, what is that?
The sum as k goes from 0 to n of n, choose k. A to the n minus k, b to the k. Okay, this is uppercase sigma. It is summation notation. Yes, it rhymes. Bwahaha. Okay, in English. Anyways, so it's a funky E.
Because I've seen that before, and I always thought like it was a paperclip. I always thought it was a sign for eggs. My mistakes aren't really there.
15 seconds. Then I'm moving on. Celine, there is some food underneath the leg of the right of the desk. Thank you. You got some trash under your desk too. Kalani. Nope, Sione. Line above. Yeah.
I'll just be ready.
Okay. Because I'm going to write what that means underneath it. And some examples.
I was like really scared.
Bates, you should have seen it. I did like a cool little back throw.
Oh, I saw it. You did it super nonchalantly too. Because you were just like,
Yeah. It was the drip.
okay. Time's up. So we're going to break this down, guys. There's a lot of new notation here. None of it's difficult. Okay? I have no idea, so my Italians and Thai people, Taiwanese, huh? Thai. That's what I thought. Okay, not Taiwan, right? It's Thai. Apologies. And Brazil. So you guys can tell me whether or not you've learned this yet. Okay? No, you're American. Shut up. Okay. So reading this, the sum as k goes from 0 to n of n choose k times a to the n minus k times b to the k. Okay, this is not complicated. It's concise. It's tightening things up, right? So, for instance, so this will give you somebody like Elias a couple minutes, but not much time. Okay, so if I wanted to write, we're going to go both directions really quick because I'm going to break this down on the next line. But let's talk about going backwards. If I asked you to write and show your work, write down and show your work of 0 plus 1 plus 2 plus 3 plus 4 plus 5 all the way to 100, right? You guys would be like, all right. Right? And you'd get there eventually. But we don't want to do that, right? Just like you guys, mathematicians, are lazy too. They're like, there must be a different way we can write this. So if we need to add a lot of numbers, which happens often, if we want to add a lot of numbers and we know the sequence that we're adding them, let's come up with a shorthand, a shortcut to write it. And they decided on sigma notation. So that's the summation. So if you wanted to do that, let me do that again. Okay? If you want to do that, if we wanted to add the first 100 numbers, right, we would say let's start at 1, and let's add to 100, and we're going to put the letter K right here. So this means change K to a 1, then put a plus sign. Change K to a 2, then put a plus sign. Change K to a 3, put a plus sign, and you stop at 100. That's what this means. Okay? You stop at that number. You start here, you stop here. Okay? And you're plugging. Now, this is the most basic formula I could give you, right? But whatever K is, you change it. In our case, K is there, and there. So K, on our formula, K will start at 0, then 0, 0, and 0. Then 1, 1, and 1. Then 2, 2, and 2. Then 3, 3, and 3. And we put a plus sign between each time.
Are we going to have like a word problem where we can see where it would be put in real life?
Oh, absolutely. And we're probably not going to get to it today, though. Okay? Okay. All right. So let's break it down really quick. And so that's what we're going to say. What does, where it says like what does, right, that mean. Okay. So that means, it means, okay, substitute values, substitute increasing values of K substitute increasing values of K to the formula and stop at N. Add each term. Substitute increasing values of K into the formula. Stop at N, add each term. Sione. If wherever N is what?
Like in the equation, like scroll up. Since N is of A to the N minus K, which go with 102.
Right. So if we went to 100, this would be 100, 100, 100. Yeah, every time. Okay. And Pishamun, I'm sorry I said Taiwanese, because I know Taiwan and Thailand are two different places. I apologize for any offense. Well, I don't think she would mind if I messed up on that, because that's not who she is.
Would have sounded dumb though, like I just did. So you're supposed to values of K. Shut up, Kaya.
Okay. Huh? What if you've already done them? Have you done them recently?
I don't think so.
Okay. Very light, not much. Bethany's getting hers really quick. Okay. The next one, guys, a little bit more complicated. This is colloquially known as the choose function. The C that I'm going to put up here technically stands for combination. So what does, make sure you focus in here. And those of you who had me for geometry last year would have got this at the end of the year. And I don't know if I taught it again, but okay, what does NK mean? So this is red. N choose K, right? Which is written as NCK. And we say choose, but it really we're taking a combination. Okay? And this means out of n objects, how many ways can we choose k of them? So for instance, if we had 3 people, how many ways could I choose 2 of them? 3 ways. I could choose these 2 people, I could choose these 2 people, or I could choose these 2 people on the sides. There are 3 ways I could choose 2 people out of 3. Okay. Now this breaks down into a formula. I am going to allow calculators. But you need to know the formula, because if at any point you guys are like, wait a minute, I don't know, you need to know the process behind it before you can just use calculators to do it. So n choose k breaks down to n factorial divided by k factorial n minus k factorial. Okay. Yeah. Yeah, you can do that. Yeah, so how to calculate a factorial is below, so why don't we go ahead and we can put this in here. We can put that there. So note, if you guys have never seen it before, we're getting a new operator, right? Beyond addition, subtraction, multiplication, division, exponents, right? All those things, square roots, right? We're now getting something called a factorial, and it takes the place of an exclamation mark. So when I read this is read n factorial. This is not read n! Okay? It's just n factorial. So. Okay. Okay.
You caused a heart attack.
Do you like get a kick out of that?
So much. Trust me, it's taught every time.
Was that on video?
Oh, yes. Okay. Oh, on video? No, just the audio. Yeah. Okay. Seth? You okay?
Yeah, I was
Okay.
up with the sun.
Okay. Now, guys, what a factorial means. What a factorial means, and I'm just going to break down the numerator here for a second because I don't want to expand it all out. Right? So we're going to have some denominator. But n factorial means n times n minus 1 times n minus 2 times, and we keep going until we hit 1. So like pick a number. 4, right? So 4 factorial would be, what's 4 minus 1? What's 4 minus 2? Okay, so 4 factorial would be 4 times 3 times 2 times 1. All right, and we stop at 1. That's all it means.
Factorial power means that. One more time. I just need to know.
Factorial means we're multiplying with whatever that integer is, then 1 less, 1 less, 1 less. So if it was 7, it'd be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay?
Are we ever going to have to graph this?
No. Well, I mean, not in this class. So really fast, let's go ahead and you guys, we had 4, and then what other number? 5 is kind of lame. Pick something.
7.
Okay. 7 or 9, I don't care. 7, okay. So as an example, 7, choose 4. So this is saying if I had 7 objects, how many ways could I choose 4 of them? Right? If I had 7 objects, how many ways could I choose 4 of them? And this ends up breaking down into 7 factorial divided by 4 factorial times 7 minus 4 factorial. Haha. I get the same thing that happens every day? Okay. Okay. Okay.
The exclamation point is like sort of
Excitement.
excitement. I'm really into this.
Okay. Sure, I didn't just jumpstart your heart, and that's why it's still beating fast. No. All right. So, what's 7 factorial? Okay. What's 4 factorial?
4 times 2 times 3 times. Wait, ooh.
4 times 3 times 2 times 1.
You did. That was weird. And what's 3 factorial? Now, guys, even though technically speaking, factorials always go down to 1 and then you finally stop. But what is 1 times anything? Itself. So does it really do anything? No, timesing by 1 does nothing. What is 1 divided by anything? Itself. So does dividing by 1 do anything? So the 1s don't really matter. So before you sit there and go, okay, 7 times 6 is 42, times 5 is 210, times 4 is 840, times 3 is 2,460. Before you do that and then divide it by 4 times 3 times 3 times 2, what should you do? Cancel stuff. Let's cancel some stuff. 3 and 2, those cancel, that's nice. 4 and 4. And what is 3 times 2?
6.
Hey, what do you know? So this whole thing was just 35. Why'd you glance away, Raymond? Because 3 and 2 were still left. What's 3 times 2? This 3 and 2.
That's kind of fun. I can't remember this.
Those 2 were left.
It's like how many
Showing it up. It's like,
Okay. Yes, Holly.
how do we get to 35 if it's just the 7 left?
7, 5.
It's the 5 and 7 left.
7 times.
Oh, right there. I'm telling you. I'm going blind.
Oh, you found okay to oh, so the degree? Everyone's lying.
Ah, much better. Thank you.
Chandler makes 5.
Little dot between the.
Much better. Much appreciated. It's awesome.
You should make that dot take up the whole screen.
Thank you.
Okay.
I remember.
Okie dokie. I am.
Part where it's the 7 exclamation and then the 4 and the 3. Where did the 3 come from? Okay. Oh my goodness. Well, I knew like there was a line somewhere, but I didn't know where.
Okay. Seth. This has got something to it. Don't worry. There's more. Okay, now Seth, the next question though is really hideous. So tune in. I need everybody to make sure they're tuned in. Okay, so this next one, we're going to use the binomial theorem to expand. And I want you guys to not write anything. Huh? Okay. Your book says expand? Oh, I should have said expand. So pencils are down. Communications ending. Eyes are up. And we are ready to go. Don't look at me like that. You're looking at me like Joseph looks at me when he's mad at me. Yeah, you calm down. You okay? What's going on, Pishamoon? Nothing? Okay. All right. So, we're going to use the binomial theorem to expand, and we've got 2x plus 3y to the 4th. Two x plus 3y to the 4th. Seth, no writing. Just focus on it, okay? I'll give you guys time to write afterward. So here, we're going to use that binomial theorem at the top of the page. K is going to start at 0. It's going to end at n. What is my n? 4. What is, so now it's going to be 4, choose K. 4, choose K, because my K is going to change every time. I'll expand it in a second. What is my A? 2x. Okay, to the n minus, what's my n? 4. Times B, what's my B? 3y to the k. Still don't write, because it's gonna, I don't want anybody to look down, be writing, and then get lost. Okay. Oh, I messed up on that one. Didn't realize. Why? Somebody answer that question. Somebody answer. I'm not hearing it. It's not because of the 2 and 3. Guys, when I have... No? Think about it here. When I have a plus b squared, how many terms ended up being in it? 3. When I had a plus b cubed, how many terms ended up being in it? 4. So if I have something to the 4th power, how many terms will be in it? 5. 5 terms.
It's always going to be like one number up than the
Yep.
next one.
So now what's going to happen here? So our n, I messed up here. This was 4s across the board, so I need to let me put those in really quick. All right, so then I'm going 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4.
Oh, I don't like
So it's the summation. I plug in 0 for k, done. Plus sign. 1 for k, done. Plus sign. 2 for k, done. Plus sign. And I stop at 4. Now, I showed you 4 choose 0. I'm going to show you something right now. Okay? 4 over 0. This was going to end up being 4 factorial over 4 factorial over 4 minus 0. No. Over 0 factorial. Okay? Side note, 0 factorial is 1. 0 factorial is 1. That's a rule. Okay? 0 factorial is 1. But 4 factorial over 4 factorial is also 1, because anything divided by itself. I don't want you guys to go through that. So right now, somebody's taken a calculator already? Nope, they haven't. I've got one right here. That's why. Okay. So right now I'm going to show you guys how to do factorials, or how to do choose functions on the calculator. Wow. Got to, huh?
What number did I get? What number did I get?
These aren't really numbered. Oh. That was Aline, sorry. Okay. Guys, I'll get them to you every time. Come on, man. Okay. Oh, still. This is going to be the awkward one. Okay. Okay. That everybody?
Hi.
Hi. Okay. Everybody got one? Okay. Okay, guys. I want you to see this really quick here, okay? So we're going to push. Here's the button combination you push. You're going to push 4. Second, which is the green button. 8, 0 equals. And you should get 1. Because what you've done is you've done 4 NCR 8. 4 NCR 0. 4 choose 0. If you look at in green above the 8, it says NCR. Okay? So you've done 4 choose 0 and you get 1. Okay? Kelsey, I can't believe you just laid there. Just let it come. I know. Miss Anna Porter also yells at me for personal space when I walk up and give her a hug, and it's making me hug her more. So. So. Yeah, she's just like personal space, personal space. Yep. She does. So, all right, guys. Are we okay with calculating that? Okay. So. No. That just calculates that. Okay? 4 second 8 0 equals just calculates that. 4 second 8 1 will calculate that. 4 second 8 2 calculates that. 4 second 8 3 and 4 second 8 4 will do the NCR for each of those. So, give me a minute.
Okay, because the M3 has to be on psi, or she's not getting the same answer.
4 second 8 0 equals.
Yeah, but it's not the point 0, 0.
Why do you have the exponents on there? Why do you have it on scientific notation?
I was the problem.
Okay. Okie dokie, guys. Shh. Come on, Schnicker. Do I need to scare you again? Maybe. Yeah. Yeah. All right. Let's focus, please. The rest, this is large, but it gets smaller as we go. Focus, back row. Seth. Okay. This is still, I'm going to give you time to write it in a second, okay? So 4 choose 0. 4 choose 0 ends up being 1 times. What is 2x in parentheses to the 4th? So that means the 2 goes to the 4th, which is 16. Is everybody all right with 2 to the 4th is 16? Okay. So 2 goes to the 4th, that's 16, but then x also goes to the 4th. What is anything to the 0 power? 1. Okay. Plus, you guys already did 4 choose 1, and lo and behold, you got 4. Now we have 2x in parentheses. I need you guys focused up here, Dimitri. Okay. I have 2x in parentheses raised to the 3rd power. 2 cubed is 8. X to the 3rd is just x to the 3rd. 3y to the 1st is 3y. Have I lost anybody? I'm just calculating out those terms now. Okay? So now I'm over, so that one's done. Where's my plus sign between them? Oh, it is. Okay, got it. That one's done, that one's done. So now I'm here. I'm on 4 choose 2. You guys did it. You got 6 times. We've got 2x in parentheses squared. That makes 4x squared. We have 3y in parentheses squared. That makes 9y squared. Plus 4 choose 3, you got 4. 2x to the first power is just 2x. Yes? Okay. 3y cubed is 3 cubed, which is 27y cubed. 4 choose 4 is 1. 2x to the 0 is 1. 3 to the 4th is 81. Y to the 4th. I don't like that 8. It got a lot smaller. I don't have to shrink my writing at all in order to fit it on one line. Then we just go ahead and do it. 16 times 1 times 1 is 16. 4 times 8 times 3 is 96. Yep, I'll buy that. X cubed y. 6 times 4 times 9 is 216. X squared y squared. 4 times 2 times 27 is also 216. Xy cubed. And then 81y to the 4th. And now we've used the binomial theorem to expand that binomial out. That's it. Guys, go and take the time to write out how to work it. If you have any questions while you write out that, you can ask me.
Were we supposed to write this?
What did I just say, Riley? Kelsey? Kelsey?
For the first one, it says 1 times 16 to the 4th.
Uh-huh.
4 times 1 is, what's that, y?
No. No, because the 3y to the 0 power just destroys it all.
Oh, yeah.
We should show this to Kaylee and see what she thinks.
No.
Mr. Bates, may I use the restroom?
Riley Parrish? Maybe. Yes.
Is this the jacket I left yesterday? Thanks, Mr. Bates. I was gonna ask you about it. The fact that I kind of accepted that was kind of sad. Wait, so
Yes, Kelsey.
We have to use that the formula to get that.
Have to? No. You could do 2x plus 3y times 2x plus 3y times 2x plus 3y times 2x plus 3y. There's also a way to use Pascal's triangle. Can anybody point out? Can somebody walk up to the board and circle where Pascal's triangle was inside that formula? Isaac?
I see like the 4, 6, 4. Is that
That's
part of it?
yeah. You guys are all a bunch of cowards. Don't want to walk up. Here's Pascal's triangle right here.
yay!
Oh, I was like, I don't. He said walk up there. You didn't know you
I know you'll do it, Elias. I still have video from that they showed at the board meeting of you doing it in your freshman year, being up on the board. You look the same.
Mr. Bates.
He's still got that baby face. What's up?
Why would they show that at a board meeting?
It was, I got employee of the month, and they had a video of me in my classroom teaching, and Elias was up on the board doing work. So.
Are you always employee of the month?
Yes.
In my mind.
In my mind.
How many times have you gotten away?
I don't know, 5, 6.
That's a lot. I've only been employee of the month one time.
It's gotten to the point where they don't want to nominate me.
Really?
Yeah, I think so.
We would nominate you.
Wait,
nominate baseball?
No, it's teacher of the month. No, you're fine. No, no, no. Stop it, stop it, stop it. That's not the conversation. Mr. Lossie got it last month, and Mr. Spots got it the month before that. And then it was some elementary school, because it's the whole district, so it's some elementary school teacher the month before that.
Y'all are better than almost all the elementary schools.
So,
Not Mr. Pistachio.
Mr. Jumonville has gotten it last year, and he got a teacher of the year 2 years ago.
Of the whole year.
Teacher of the whole year.
Are you teacher of the whole
365
year?
days a year?
I have been teacher of the year.
How many years in a row?
Nobody's ever. I did. Joseph, she's picking up your attitude. She's picking up your attitude. Pishamun. There it is, right there. Wow. Huh? I can't hear you, Joseph. I always need a hug. Can you pick me up and let me wiggle my legs like a little girl?
I'll try.
All right. Wee. All right. I think you guys honestly have way too many opportunities for sound bites on these videos. You have them all written down? Okay, here we're gonna, well, it's not even like I'm not gonna go to another screen right now. So why don't you guys try, for the last 11 minutes of class, I want you to try workbook problems 1 and 2 at least. Workbook problems 1 and 2 from 6-3. There you go. Workbook problems 1 and 2. Workbook problems 1 and 2. Do you write them down on the page of notes as you go? What did I write? It.
Don't do it. And then we have done in all caps.
We have, that was not necessary, but I wrote
We erased
necessary.
in that board.
And then I know information. Now we have our new one. It's okay, by the end of the year, it'll be all full.
It's funny. I think most teachers, when they know that they're being recorded, they change the way they speak. I'm just stupid, I suppose. Yep. Since you guys are doing workbook, I'm going to go ahead and stop the video at this point. There's no reason for me to continue it while you guys just have it on. Huh? Do an outro?
Catch you guys later.
Alright, thanks guys.
Like and subscribe.
Follow, subscribe.
Oh, right. No.